Welcome to an Achieving Science video. This video is going to look at alcohols. Let us begin by looking at this structure. Hopefully you can name it. First of all, we need to look at what elements are in it, and we can see that there is carbon and hydrogen. So it is a hydrocarbon. Next we see if there are any double bonds. There aren't any, so therefore this is an alkane. Finally we look at how many carbons are found in it. We can see that there are 2. And therefore this is ethane. This is an important structure because if we compare it to the one on the right hand side, we can see that one of the hydrogens has been replaced with a functional group of O and H, as shown here. This makes it different. This makes it an alcohol. So an alcohol is where an alkene's H has been replaced with an OH group. Has a general formula CnH2n plus 1 OH, where the N is the number of carbons found within the molecule. We'll use this later on. Let's look at naming them. Naming alcohols is just like naming alkanes and alkenes. It is referred to as the number of carbons found within the molecule. I remember this by MEPB. That's the beginnings, the prefix of the name. So it's meth, eth, prop and bute. So if it contains 1 carbon, it's meth, 2 carbons, eth, 3 prop, 4 bute. MEPB. With an alcohol then, we need to then finish off its name. All alcohols will end with anol at the end of them. So we form methanol, ethanol, propanol and butanol. Next let's look at their structures. If we use the general formula, we can work out how many hydrogens, carbons and oxygens there are within the molecule. Remembering back, methanol contains only 1 carbon, ethanol 2, propanol 3, butanol 4. We can work out then their general formulas as shown on the screen. Using these chemical formula, we can then produce a structural formula. This is just like making up any other alkane, except for instead of having a hydrogen, there is the functional group of OH on the end instead. Therefore we begin with methanol. Remembering that around all carbons there should always be 4 bonds. 1, 2, 3, 4. With the OH group on the end, methanol. If we add another carbon, we form ethanol. This time we can double check that carbon has 4 bonds around it. 1, 2, 3, 4. This second carbon has 1, 2, 3, 4. And we have the OH group on the end. This is ethanol. Propanol will be 3 carbons in a chain. And then butanol will have a 4th carbon in the chain. The reactions of alcohols are then important. As we've seen, all alcohols contain carbon and hydrogen and oxygen. So if we react any of these alcohols in air, in particular the oxygen that we're going to look at in air, we see that carbon reacts with oxygen to form carbon dioxide, hydrogen reacts with oxygen to produce water. So in every single reaction, we can see that the products formed are going to be carbon dioxide and water in every single case. If we then look at the reaction with water, they always produce neutral solutions because they dissolve. If they react with sodium, they produce hydrogen. And if they react with an oxidizing agent, they will produce a carboxylic acid. We'll cover this in a lot more detail in a further video. For the meantime, we'll just mention what effect the oxygen has. If we begin with an alcohol, where the R stands for anything that goes before this last carbon with the OH group on the end, we can see that by adding oxygen, this slightly changes, and the group changes to form a double bond oxygen with a carbon, and then this OH group remains. So a COOH group is the functional group of a carboxylic acid. Ethanol then is non-toxic, as the main alcohol in alcoholic drinks. Alcohols are used widely in the world around us, so one use is within alcoholic drinks. We would never use methanol though, because methanol is toxic and this would cause damage to the brain and the liver. Other uses of alcohols include solvents. So ethanol and methanol can dissolve most compounds that water also dissolves. But they can also dissolve substances that water cannot. This means that if you draw on your desk with a permanent pen, if you try to wash it off with water, it wouldn't dissolve, it would stay on the desk. But if you used ethanol to wipe it off, it would be removed because the pen would dissolve in the ethanol and therefore could be removed from the desk. Meths. Full name to meths is methylated spirits. It is used as a fuel and also used to clean paintbrushes. It is a mixture of ethanol and other chemicals. But it is highly toxic. Because people think that it contains ethanol and so it's an alcoholic drink potentially, we need to make sure that people don't drink it, and therefore it's coloured purple, because if people did drink it, it would be very toxic. Alcohols can also be used for cars, so ethanol, methanol and protanol and butanol are all fuels. Ethanol can be added to petrol and used in cars, where the higher the concentration of ethanol, the cleaner the fuel becomes and more environmentally friendly. We can also use plants to produce alcohols. This process is called fermentation. This is where sugars are used and converted to ethanol using yeast. This tends to happen at 37 body temperature in a process of anaerobic respiration in slightly acidic conditions. This can be shown by the word equation of sugars converted to ethanol and carbon dioxide. So this is an alternative way of producing ethanol. Finally, the final use we're going to look at is using ethanol within perfumes and aftershave lotions. Ethanol is used because it's got a lower boiling point, which means it evaporates more easily. The ethanol is mixed with other fragrances which give you the smell and water.